In this tutorial we will make a looking time analysis, and I will start off where I stopped the last tutorial. I have 3 subjects here, and I've read the data that I've exported from ProLab into TimeStudio with core read file fast, and I've interpolated the gaps. And the next step is to select which events or which stimuli we should use in the analysis. And I do that by using the event modification plugin. It looks like this. And if we type eye tracking here, we can scan the event names to get a list of all the stimuli that we have in the data file, or actually all the events, data events in the file. For this task, we have a colored image and a grayscale image that are either on the left side. Here, the color is on the left side in this stimuli, or on the right side. But as you can see here, this is the end event saying that the stimuli is over, and we want the start. So we can remove all the other ones so that we only have these events, which are the different stimuli that we have for the preferential looking task. So I will select all and copy this and put it into Excel like this, and then you can see that this is actually a table that is aligned with tabs, and we'll change the name of these events by adding a new column called name, and we'll call this event for only color left. So we are actually not interested in the actual image, but only that this stimuli has the colored image on the left side. I'll do the same thing for the right side. Like that. And if I select everything, I can copy it back here. Also make sure that you match on the events field. So don't change this one, and then you can save it. So if I run this event, it will change the name of these events to color left and color right. So the next step is to check whether we have any artifacts in the data, and we can do that also with an events plugin. Events reject that look like this. Again, we're interested in the eye tracking data, and if we look at the different events that we have in the list, you can now see that in the end we have color left and color right. You can only choose one event in this plugin, so let's start with color left, and let's look at time 0 at the onset of the stimuli to 5 seconds after. We can then plot the data. So if we take time on the x-axis, we can have the gaze x-coordinate on the y-axis. And if I click on any of these squares, which represent, well, we have the subjects here, and these are the trials. So we have 3 trials for each. If we look at, if I click here, we get a plot, and I can use the arrow keys to move between trials to see if the data look good or not. So sometimes you have a lot of missing data, and you might want to exclude trials that have less than, for example, 50%. And you can enter that here, but in this case all the data look actually really good. Not much to do about this. Maybe this one had some artifactual data that is a bit hard to interpret, and if we don't want to include this, we can reject it manually by pressing space. It will turn red. If you unreact this one, you can get back to the default state. You can also plot the data as a gaze plot and use X and Y coordinates. It will then look like this. As you can see, the axes change for the different trials, and you can then specify to limit the axis of the graph. So this is the resolution of the screen. And now it looks very much like plausible eye tracking data. So the artifact is in here, it's in the same on the same side, so it probably won't affect our data, and I suggest that we keep this trial. So save the setting. Now this plugin didn't end up at the end of the list, and then we can move that plugin further down like that, and if we run that plugin we can see that none of the trials were rejected. The next step is to start with the actual areas of interest analysis. We then change to the eye tracking plugins and start with AOI clear. So this will store, this will clear all the AOI data that is stored in memory. So you can run multiple AOI definitions after each other, and if you run them without clearing it, it might stack up. So good practice, always add this one at the start of the AOIs. And then we will make an area of interest definition. The plugin looks like this, and it's fairly complicated, but I will just make it as simple as possible. We will use the eye tracking data, and we will look at the left, where the colored image is on the left side. We choose a time range between 0 and 5 seconds. We can browse for an image. So for example, this one has color on the left side. We have to change the resolution of the stimuli or the recording screen. So this is what it looked like. And we now want to create AOIs that we can put on the stimuli. So if we start with creating an AOI that is called color, you can double click on the screen to place it, or you can write the position here in the text box. The size was very small. I suggest we make it larger, like that. And because the eye tracker isn't always accurate, there might be a small offset, we suggest that you add some padding around the stimuli. So for this tutorial, I will just keep it like this, not very precise. And we then need to add another area of interest, which is the grayscale. And again, we can double click to position it and change the size of it, like this. And that's it. Let's call this color left because it's on the left side. And if I now run this plugin, it will look for all the stimuli that we called colored left and see how much looking time it had in the two AOIs. So we also need to do this for the right side when the colored image is on the right side, and I do this by duplicating the plugins. So I get a copy of it and I open it. I will start with saving it with a new name, color right, and then we'll have to change the position. And now you can see that the stimuli is wrong, so we can just choose another stimuli. Like that. We now have the color AOI on the right side and the grayscale on the left side. And I run this, and it will find all the gaze points in the two AOIs. Now, to get the results for this, there is a plugin called eyetracking results that we can use. And then we can choose the two different AOIs and calculate the mean of the trials. And we're not interested in latencies, we're interested in the looking time. We can take it in percent, and we can also change the output format to long. Do it like that. And if I run this plugin, I will then get a 3 3 windows with data. And as you can see, I made a mistake. The bars are exactly identical, which to me is a sign that I did something wrong, and I know what I did wrong. So in the AOI definition, we are still looking for color left, so we have to change this to color right. Now it's very good that I can clear all the AOI data before I run the definitions again and get the results. So let's try again. And then it looks like this, which is much more plausible. You also get the info, overall information about the different subjects, and a detailed list of what happened in each trial. So if we select all of this and go back to Excel and paste it there, we can see that this is a format suitable for statistical analysis, perhaps using linear mixed models, something like that. So we got the name of the events, and for the different AOIs, the percentage of looking time. And that was about what I was supposed to show in this tutorial. Thank you for now.